I will try and stay on task as possible so we can get as much reviewed as possible. So a test blueprint tells you everything that will be on the test. I did like your comment on Twitter. I haven't liked it yet, but I will like it. I still, maybe that wasn't mesmerizing to everyone else, but I still can't see how you girls could do that. Spell those letters out with your pom-poms. It is, huh? I've probably watched that video 25 times. Well, my mind was straight up blown. Yep. It was awesome. It's just like magic. All right. I just barely said I'd stay on task. Fail number 1. Here we go. What is it? That was just a note page. You do whatever you feel like with that. I would use it to study tonight. All right, here's the test blueprint, 15 multiple choice questions. You will see every one of those today fairly quickly. All right, there are 8 questions from Chapter 2, 7 questions from Chapter 3. Of those 7, I'm reliving it right now. 4 are naming or writing formulas. You will see these today. Now, when I say you'll see them, I've gotten rid of the answers, but you'll see the questions. All right? Then, so these are the multiple choice, and then there's 3 where you are given a written chemical equation and you have to write it as a, Yeah, that's fine. I gotta sneeze. Okay, we will do one of these today. Percent composition. To me, this is the easiest question of the test, so hopefully that makes sense. We'll go over it today. 1 combustion analysis problem and 1 limiting reactant. So this is the goal of today. So let's get after it. Are you ready? Now, there would be options right here to choose from, but to feel like I'm testing you at all, I've gotten rid of those. So here we go. Elements blank exhibit similar physical and chemical properties, and this is more than 1 word. So talk with your lab partner, 15 seconds. How do we know about elements that would have similar physical and chemical properties? Ready, discuss. Not me, him. Okay, that was a good solid 15 seconds. The answer, and I don't know, I didn't even look at these before I blanked them all out. But the answers will have something to do with it being in the same vertical column, the same group, or the same family. All 3 of those answers are the same thing, right? So these would have similar properties, but like the 2 stars and then whatever over here, this would definitely not have the same properties, right? Okay, this second question right here, it says, which pair of elements below should be the most similar in chemical properties? 10 seconds. Tell your lab partner how you would know that. Okay, I heard the word same multiple times. And that's good because this is the same question as this, and same means the same family, right? You're looking for the pair that is in the same family. If there's more than one, so let's say it's like A, B, C, and D, and you have A and B, A and D, they're both in the same family, but choose the ones that then are the closest in the same family. Are we okay with that? So far in this review, make sure you know that elements in the same family have similar properties. That's what those 2 questions are trying to elicit that you know. All right, this one, not hard at all. Which one of the following does not occur as a diatomic molecule in an element? Does not is important here. So I'm testing you whether you have your diatomic atoms memorized, right? What? Yeah, HNOFClBrNi. Those are your diatomic elements. H-no-fluchlor-bri. All right? So this answer would simply be one that is not here, like Na. You're like, whoa, that's a metal. That's not diatomic. And we move on. Easy enough? Okay, so far, elements in the same property, family have the same properties. Next, you need to have your diatomic memorized, which are right there, except for Na. That was the example of what would not be one. Okay, moving to the next slide. And by the way, a few people took pictures. I could not care less if you take pictures of this. This is fine with me. All right. A molecular formula always indicates. This is harder in Jeopardy to just figure out what we're looking for. But for this question, it's trying to get you to know the difference between the molecular formula and the empirical formula. You may recall the empirical formula is the lowest ratio of atoms in a compound. The molecular formula is the actual ratio of them. Like what is everything there is there in the molecular formula. This one is the one reduced. So sugar's molecular formula, C6H12, that's a 20. O6. Empirical formula would be what? CH2O. Okay? The molecular formula shows you everything. The empirical shows you the lowest ratio. Okay. All right. Which of the following is the formula of, and I erased this word so you wouldn't just memorize it, but you need to know how to name an acid. Or, if you look at Chapter 2's note page in Canvas or on behsscience.com, there's a link that says common acids to memorize. I do not require you to memorize, but there are 7 common acids. This is one of them. If you have them memorized, this will be a very simple question. If you don't, it might be a little bit harder. Okay? But so far now, elements in the same family have the same properties. We need to know the difference between molecular and empirical. I'm going to ask you to know how to name an acid, and then what was this other part at the bottom? Oh yeah, diatomic. Those are the things so far you should know. All right, this one, which formula/name pair is incorrect? So it's 5 options. It'll be like NaCl, and that'll be like sodium chloride. Okay, and that one would be right. And then it'd be something like NaF, and it'd be like mono, sodium, monofluoride, or something like that. Okay, where this is definitely wrong. Yeah, this would be, and this is not the example, but I'm just showing you like how it will be put. The one that is wrong on this list, if I remember, it's like this, where it gives prefixes for an ionic compound. We only use prefixes when we're talking about what type of compounds. 2 nonmetals together. All right. Then, this one. Which of the following compounds is yada 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 1 chloride? So you have to be able to name some stuff. We warned you. This one's writing a formula. But there's something nice about this problem. I got rid of, this is just some metal. All right. And it's a transition metal. How do I know that, by the way? All right. So I have to specify the charge. All right. Now, if this is a 1 and this is chloride, what do you know about this formula? It's already balanced, meaning this will not have any subscripts. That's kind of nice. Thank you. What? Yeah, I cut this from the test this morning, Will. Oh. All right. So, whatever this is, so let's say it's lead 1 chloride, it'd just be PbCl. This is a 1, this is a -1, no subscripts. Try to remember that tomorrow. There'll be a lot of them that have subscripts. And I would not be surprised if there's ClO3. Like PbClO3, you're like, oh hey, no subscripts, but this is chlorate, remember. Chloride just means the element. Okay, next. I know these are small, but what else? A molecule of water, these are all the ones from chapter 2 right here, if I remember right. Bless you, bless you. A molecule of water contains hydrogen and oxygen in a 1:8 ratio by mass. This is a statement of the law of something. This is from chapter 2. You can study that. It was one of so-and-so's whatchamacallits. Could I be more clear? All right. No. I've already tested you on this, by the way, and I told you it would be on this test as well. Yep. So you may recall my questions are pretty constant. All right. Which one of the following is not one of the postulates of Dalton's atomic theory? Dalton has 4 main theories. All right. So they'll be listed, and then one of them won't be. It'll be something completely wrong. Okay? So, what's that? I don't remember if it's super obvious. So you might need to know a little bit about Dalton. You might need to know a little bit about Rutherford and the gold foil experiment. The gold foil experiment is famous for discovering what? All right, the nucleus or the proton. Okay, so whatever this answer is here, it probably has the word nucleus or proton in it. Okay, this one right here is the literal definition of an isotope. You can write this sentence down. Well, no, these answers should be in your notes or you have read it. Isotopes are atoms that have the same number of blanks but different number of blanks. It's just a straight vocab word. It will give you both of them twice, but they'll be in the wrong order once. And then it'll have words that, like electrons, that have nothing to do with it. Okay, so far are we okay? Do you need me to be on this slide any longer? Okay. Okay, I'm going to move on. All right, this is the last slide of multiple choice questions. The correct name for, and there's something missing here, by the way. It's not just HCO3. If it was HCO3, it'd have to have a charge because that would be a polyatomic ion, right? Metal. So like if it's Na, then the name would be sodium, hydrogen, carbonate. So at a minimum tomorrow, make sure you know HCO3 is what? Hydrogen carbonate. And then you just have to know the name of the metal that goes in front. Look at this. There's no number out here. So you know whatever this is, it's got a charge of 1. It doesn't look like there's enough room for an element and a Roman numeral, right? So you know that it has to be either lithium, sodium, potassium, rubidium, or cesium, hydrogen, carbonate. Because there's no subscript. Now, if you don't know that, that's fine if you didn't know that, but know what HCO3 is. Okay, this one you learned in 3rd grade. The nucleus of an atom contains 2 things. Can you tell your lab partner?
We're not talking about cells either. She said DNA.
And mitochondria and the... Oh, sorry. Yeah, sorry. I was just naming all the cell parts. I'm sorry. Yeah, all that stuff. Yeah, we're not on that, though. Okay. Bio makes me, like, gag. It's disgusting. The word Golgi apparatus? Yeah, cringe. Okay. When a metal and a non-metal react, the blank is the loser. I've said this 20,000 times. Who's the loser? Metals. Good. And then the non-metals are the others. All right, here we go. The last one. The charge of the blank, so it's either manganese or fluoride. And when I cut this, I cut E off on accident. The charge of whatever is this whatever salt for F whatever. I blocked out which one I'm asking, but it's either what 2 answers are the options here. Yep, and what are their charges? All right, +3 -1. So it's one of those two. Manganese is a Roman numeral. Sorry, it's a transition metal. So you wouldn't know, except if you know the hop and swap, that has to be a +3 because fluoride's a -1. Okay. There you go. You'll be ready. I'm set. Here we go. Now, that's all the multiple choice. So now this is an example, and this is very different from what's on the actual test. So don't memorize this. This is just an example of what the question type will be. So this, on that like blueprint part where we said, hey, there'll be one of these, 3 questions where you are given the written chemical equation and you have to write it and balance it. So that's what this is. So I'll give you a couple minutes to try this. If you don't know what sulfurous acid is, don't panic because it's actually not on the test tomorrow, but try and figure it out. Ready, set, 2 minutes. No. All right, so you know it has to have hydrogen. Hydrogen's diatomic, so there's your bubbles, but there are still 2 things left over you can't just ignore. So zinc must be hanging out with who now? Sulfite, which is SO3, and it's a -2. Zinc is a +2, so no subscripts here, correct? So then you go to balance. The only subscripts really is a 2 here and a 2 here, and that's on the same atom. Now, I'm ignoring the 3, remember, because it's part of the polyatomic ions. So we don't, it is a subscript sort of, but it sort of isn't at the same time. So since it's already 2s and 2s, everything's already balanced. All right. Now, I feel some positive vibes over here. That feels good because it's been a negative vibe day so far. But we'll be fine. You don't pass the test. Never mind, it's hopeless. I'm just kidding. There's always chapter 4. It's hard stuff, but it's just more of this. It's the hardest test. Okay. Anyway, this question is harder than any of the 3 on the test. This one is harder. All right, on the test, the 3 of them, the first one is a composition. And I might not have an order. Comp is just where A plus B goes to AB. So that one's pretty easy. You just combine the 2, make sure to balance charges, and then balance the reaction. I'm giving you a periodic table, and it tells you, the first 2 tell you every piece. So it's not like you had to guess what this is. It will say zinc sulfite. All right, the second one is a decomp. And I know we haven't gone over these types, but we will, and it's not really that necessary to do this. Decomp is just reverse. And I'm going to tell you right now, because I told first hour, this is the decomposition of a metallic. At a minimum, so far, we should have this one ready to go for tomorrow. Carbonate is CO3, and it's a -2. And then what was the other polyatomic ion it said you needed to know? Hydrogen carbonate, and then it's a -1. Those are, for your exam, those are 2 important ones to make sure you have memorized. Okay, the third equation. This H thing, but then you should know it reacts with what? O2, and you should know it always produces CO2 and H2O. Yeah, the 2, and then balance that, do the math, and then you're ready. So those are your 3. A plus B goes to AB. Decomp. AB goes to A plus B, and remember, it'll be a metallic carbonate. And then combustions. There will be a number here, a number there, and then you're off to the races. Good. I like that. Okay. Next, what is the percent composition of Mg and MgCO3? This is not the exact same one on the test either, but this is the one I hope it's where everyone will at least feel confident about something. If you don't know how to do this, you take the mass of mg from the periodic table, and it's 24 grams. You're going to divide 24 by the total mass, and then just multiply that by 100. So the total mass, mg is 24. Oh. Carbon is 12. 3 times 16 is 48. We get 84 grams. So we put 84 in the denominator. 20, because we're finding a percent. All right, so 24 divided by 84 times 100 is like 26 point something, if I remember right, last hour. 28? All right, sorry. 28-ish percent. And that's all. You've done this your whole life. This is how many you got right on the test. This is how many there were on the test. And then you multiplied it by 100 to find your percentage. So you take the part, you divide it by the whole, and multiply by 100. So hopefully we can at least get 5 points tomorrow, right? Okay. We are so much faster than we were last hour. Here we go. This is a limiting reactant problem. It is purposely written to be one that is easy to work through quickly, because we're just going to use it to review the steps. Will you take, I gave them 8 minutes first hour. We have time that you can take 10 minutes on this problem if you need it. Oh, this probably wasn't super fun. The first thing you do is you take both your given masses and you solve for one of the two products. Now this one only had one product, but we have been doing two. And it's just one more picket fence, so it's fine. Now, the overwhelming mistake kids are making today, please look at the screen, is right here. And I know why you're doing it. You're putting 3 grams of H without the 2. That's because in combustion analysis, we end up with an H by itself. And that is fair because in combustion analysis, we're literally trying to find the ratio of H to O. So that way we can ignore the 2. It's accounted for in a different spot in the picket fence. But when we are doing limiting reactants, we have to put the exact identity of the reactants. We don't break them apart. We put exactly what there is. So that mistake has been killing kids here. So it's H2, which means on the bottom it's H2, 1 mole, 2 mole, 2 mole, 1 and 18. We got 27. Up here we had 50, 32, 1 mole, 1 mole, 2 mole, 1 mole, 18 grams. This was 56. The larger thing, you're supposed to cross everything out there and never even think about thinking about it again. Then, this gives me a couple answers. It tells me my limiting reactant is H2. It also tells me the mass of water that was created. I'll get rid of this thing now. Right. There we go. Okay, so I was able to put those. It's kind of ugly, but they're right here. It also tells me the mass of H2 at the end is going to be 0. So then I have these. Oh my, whatever. Okay, then the next picket fence is to find my amount of used. What is going on? Oh my. It's going to tell me the amount of used material. So I start with my limiting reactant and I solve for grams. This has gotten all screwed up. Of oxygen used. What happened? If you go off the screen and I hit a certain part, it converts the mouse to a different thing. I didn't notice, even though the message told me it was that way. Okay, when we solve this, the other problem, first and second hour, both of you guys have struggled, is that you get 24 and you write 24 in your answer. But 24 is not your answer. 24 is how much you used. So you take your initial mass of oxygen, you subtract your used, and you get 26 grams of excess. Then you have three answers. And let's review these. The answers are 27 grams of water created, 0 grams of H2 because it was limiting, and 26, is that what we just said, right? Grams of O2. This part should always add to your initial mass. You take these things, you add them together, and you get 53 grams. This is how you check if you're right. You go back to the problem. I gave you 53 grams. If these match, then you know you did the problem right. Okay. Okay, what do we think? There's a ton of resources on my website for limiting reactant if you're still struggling. There's like class videos with probably up to 5 times of me explaining it. So, all right, here we go. The last part would be this problem. And we are down to what, 15 minutes? 10 minutes? What time do we got here? Okay, so we got 10 minutes. You do your very best for 5 minutes. A 3.87 gram sample. This is probably distracting. Let's just get rid of all that. Go away.
It will never go away.
Okay.
It will always come back.
So this is a combustion reaction that does contain oxygen. Try and follow these things as quickly as you can. No. Have my friendship.
If I miss this question completely on test, how many points will I miss?
A lot, 20. Just don't miss it. No. You got to find grams and moles. You find the grams of C.
What? No.
Are you here Friday? So the rules on this would be the ones on that handout I gave you. That. The steps to this are on the little handout I gave you. Oh, I've been recording this whole time. All right, so quick, grams of CO2, 2 grams of carbon, grams of water, 2 grams of H. Then I took the initial mass I was given in the problem of the CHO, and I subtracted the 2 masses I just found. That's the whole reason I had to find those masses of C and H. And I got 2.11 grams of oxygen. Now that I have the grams of all of them, I go back and what the freak are you being stupid for? All right, sorry, my temper's rough. I took both of the grams, or all the grams, I mean, and divided them by their respective molar masses. So carbon's molar mass is 12, hydrogen's molar mass is 1, oxygen's molar mass, it's crossed out right there, but that's 16. Once I did that, I then had them in moles. And once I have them in moles, life's good because I'm used to this. Once they're in moles, I take all of them and I divide by the smallest of the three answers. The smallest was 0.13. And we're off a tiny like hundredths, but it doesn't matter for right now. We ended up with 1, 1.33, and 1. So then to make 1.33 a whole number, I had to multiply it by 3. And I have to do the same thing to every piece. So this ended up to be a 3, a 4, and a 3. And that gave me my mass. Or not my mass, my formula. C3H4O3. Now, there will be a secondary part on the test. It will say, hey, if this is roughly around 200 grams, what's its molecular formula? And this one's way off. I made up 200 because I didn't know off the top of my head. But if it's 88, 88 times 2 gets you roughly close to 200, so you would just double everything. On the test, it's like exact. Well, it's not exact, but it gets you in the range. Okay, there are some